Did you remember to study for your test?
Garrett, be 100% honest. Has this microwave always been there?
Yes.
You're shitting me. No. There's no way. This is just appeal, alright? This is just materialized.
Cole, I didn't think you were going to be here.
Well, I was at the Special Olympics for baseball or whatever, but I told Coach I would have a test, so.
They didn't need you to play?
No, it's not. Alright, I gotta turn
So
this.
if I'm not going to take it, do I have to take it today or can I have it?
That's not anything.
You can take it next week, but there's only one day
I'm
next
pretty
week.
sure,
Thursday.
at least it hasn't been here
Thursday's the only
in
move.
this spot.
Okay. Do I have to
always
sit out
there.
in this week?
No, you can stay in here, but you should be using your time to study though if you don't feel like you're ready.
Could be the fact that just don't look at the scenario.
I had a testing job. I had testing Spanish.
Spanish, you should on it.
Cole, it's not as normal as me.
Yeah, bro. Nobody else does that.
I look at every single person
I've been the answer. Does everyone break your
Are we supposed to grab these papers?
Yeah, before or after the test, either one.
1.1.
Oh, Jedediah's not going.
Yeah, but like this is the very beginning. We started doing four. Why are we all the way back in one?
I got lead. I got 47.
Finish your home study. You're probably gonna do the first 1%.
All right, a couple quick things before we get started. If I don't have your test review in Google Classroom, make sure you give it to me before we get started with your name on it. Any late work, incomplete work, this is also your last chance for points. Not after the test. It means you don't need it during the test, so turn it in now. And I need your phones and smartwatches put away, please. Test is no calculator. So go ahead and put your stuff on your desk.
Like hypothermia.
I freaking last
It
night.
feels like
I had to get ready for the Spanish test,
they're turning black.
but I might as well.
Fall.
I
I'll listen to the audio, but no. The Aflac.
He would figure out how to do it.
Wisconsin, it's terrible.
No,
I can't hardly do it.
anybody in Siberia can do it.
Okay, does everybody have the test now? I didn't skip anybody. Okay, so this does total up to 50 points. Every question except number 1 has partial credit possible. So please try to show me as much work as possible. Show me your thought process. That way, if your final answer's off, I can still give you the points that you deserve. But you can't grade what you don't put down on paper. Especially the last 6 questions. 6 points apiece. So you show little to no work, and if it doesn't work out, which I don't know how it would work out on some of those, that's an instant 6 points gone. So that would be kind of rough. There was one typo on here, but it doesn't really affect much. In the top left, if you have form B, it accidentally says test 3132. This is actually test 3334. So it doesn't impact the test at all, but it does have the wrong title if you have form B. So 50 points. Last thing that we're doing for logarithms, feel free to, you're certainly encouraged to try to check your work. Some of these you can check by hand even though you don't have a calculator. And once we have all of the tests in, we'll start going over the handouts you picked up and we'll talk about the next unit and stuff like that. But test is certainly more important for now, so give that all of your attention, please. You gotta wait for the pass to come back. You gotta wait for the pass to come back. think we have all of the tests in. So let's talk for a minute about the next unit, because it's going to feel quite a bit different. Different pacing, different topic. We are 100% done with logarithms, other than the final exam, of course, unless you get to exempt that. But our next unit, I would say the content's a little bit easier, but then the trade-off is we don't give you quite as much time to digest the material. So this is about a 5-day unit, so we're going to spend roughly 1 day on linear stuff, and that's the handout you guys picked up. And we may not have time to get all 3 of those, but really I'm going to go over worksheet 1 with you. If you want to go ahead and number those, 109, 110, and 111. And what I'm going to show you on 109 just gets repeated for practice on 110 and 111. So it's really just one worksheet of stuff. That's all the linear that we expect you to know. Then we'll spend basically a class on quadratics, basically one class practicing a little bit more piecewise functions, because we're going to look at a little bit of that today, a day for review, and then a 5th day for a test. So I don't know that the next test will be 50 points. It might be worth a little bit less than that. But most of this stuff should be familiar to you. But there are going to be a few things kind of sprinkled in. I think all of quadratics should be familiar to you. Piecewise functions are not new to you, but you just haven't gotten to practice so much. And then the linear stuff we're about to look at is mostly Algebra 1/ACT stuff, but there is a couple of questions mixed in there that you may not have learned in Algebra 1. It just kind of depends on your teacher and all of that stuff. So let me go ahead and do a quick little reteach with this 109. So you need to join us here. Obviously, you're working on something for another class because you were finished with your test. That's great, but now I need you to rejoin us. And the first 4 questions talk about writing the equation of a line. So before I just dive in and start working these, there's a couple of different formats that you need to be familiar with. Notice the directions talk about 3 different formats. So the one that I'm going to use 99% of the time, and I hope by the end of this worksheet I convince you to use it 99% of the time, is one called point slope. This is what we like to use in calculus because it is easier than the one you guys like, which is slope intercept. Slope intercept is a good one to help you learn graphing. It is y equals mx plus b. Now, we still need to know this because that's how your calculator graphs things. There are a question or 2 on this worksheet where we will need slope intercept form or ask you to put an equation in slope intercept form. But point slope, unlike slope intercept, also needs the slope, but instead of specifically needing the y-intercept, slope intercept, this is about the y-intercept, you can literally plug in any point into x1, y1. So if you have a slope and a point, these are the 3 things that you change to numbers. The point goes in for x1, y1, and the slope goes in for m. Now, there is a 3rd form, and I'm not going to speak on this basically at all other than right now to give you some perspective, but there's one called a general form that used to be a more common thing. Some people think that it's easier to find x and y intercepts with, but these are also reasonably easy to find x and y intercepts with, so I feel like this is kind of silly to learn an extra form. But, so that you've heard it before, this is what general form looks like. You put the number of x's first, then the number of y's, and you set it equal to the constant. Part of why I think this may have fell out of fashion is at the college level, professors consider general form to be different things. All professors consider this to be general form, but then some professors say that a needs to be positive. So like if it was negative, you just multiply everything by negative. And some professors say not only does a need to be positive, but it needs to be a positive 1. So if a was like a third, they would expect you to multiply everything by 3. So for that reason, just for the inconsistencies, basically no one talks about general form anymore. But I guess if you remember that from Algebra 1 and you use it correctly, I certainly wouldn't count that against you. But notice for both of these, we're going to need to know slope. So there's two good ways to find slope. Slope, we like to use the letter M. If you have a graph, you can just count rise over run. But more often than not, what you're going to want to do is the slope formula. And again, this stuff shows up on the ACT, so in addition to our class, this should help you. Even though you should know this stuff, maybe you'll be a little more familiar and be able to work them a little bit quicker. So subtract the y values to calculate the rise, and then in the same pattern, subtract the x values to calculate the run. These are the things that I need for question 1 and 4. Okay, so question 1, make an equation that goes, a linear equation that goes through these two lines. Well again, I'm always going to use point slope, and they gave me 2 points to plug in. So I guess you could plug in this point or this point, it doesn't matter. I typically just plug in the first point just for consistency, but it really doesn't matter. The y value goes in place of y1, the x value goes in place of x1. And then minus and negative becomes plus. And then really the only thing keeping me from my first answer is I still need to figure out the slope. This is why point slope is so easy. If you have a point, you just plug it in as the formula tells you to. And then for slope, you could either make a graph, plot these 2 points, count rise over run if you wanted to. It's a whole lot quicker to just subtract the y values and then in the same pattern subtract the x values. Slope would be -3. Now, I'm not going to talk about this very much, but I guess there is a few times on the AP Calculus where we do multiple choice and the answers may be in slope intercept instead of point slope. If for some reason you just can't break the habit of slope intercept, I just want to point out to you, if you can do point slope, to get it in slope intercept, you would just need to distribute the -3 and then add the 6 over. Then it's in slope intercept. So point slope is just easier to set up, and if you really need slope intercept, then 2 steps later you can get it if you need it. Now, if we can do question 1 this way, then we can do question 4 the same way, because it's 2 points. I can do point slope form. Just take your pick. Whichever point you want to use is x1, y1. So 5 goes in for y1, 0 goes in for x1. Again, I just picked the first point just because it doesn't matter. And then really the only thing that slows me down a second is thinking about the slope. So make a graph, plot the points, count rise over run, or even quicker, subtract the y values over subtract the x values in the same pattern. Looks like the slope would be 5/2. I guess the only thing I would probably do different here, since subtracting 0 doesn't do anything, I probably wouldn't write that part, but I guess it's technically correct. So, be able to find the slope with slope formula and or counting rise over run. Know point slope form, memorize its formula, plug in a point for x1, y1, plug in the slope for m, and you can do those questions. Now, these skills are going to carry over in the questions 5 and 6 also. So, now question 2 throws a little bit different at us because it doesn't give us 2 points, so I can't do the same thing. But instead, it reminds me or tells me that this line is supposed to be horizontal. So there's a few questions on this worksheet where you need to remember a few things about horizontal lines and vertical lines. So you need to write down the things that you do not remember as I say them. Okay, horizontal lines look like this, whereas vertical lines look like that. You need to know the slope of each of these. And technically, if you forget the slope, you could always just take 2 points, count rise over run. This has 0 rise over some run. 0 divided by another number would be 0. Over here, if you took 2 points and did rise over run, it has no run. When you try to divide by 0, is undefined. And the last thing that I think is helpful is to know that horizontal lines will always end up in the form y equals a number, whereas vertical lines always end up as x equals a number. So we really need to know this stuff for question 2 and for some later questions. So again, at least jot down the parts that you didn't remember, or just all of it if you want to be safe. So if I start treating question 2 like I did 1 and 4, I can say, all right, I know what point slope form looks like. I know I can plug the y value of a point in for y1. I can plug the x value of the point in for x1. By the way, I'm changing this from a minus to a plus. Somebody asked about this first period because this was minus and negative, so I just changed it to a plus a positive. And then the last thing I need to know is the slope. But since they tell me it's horizontal lines have a slope of 0. So you can put 0 in place of m. But 0 times anything is going to be 0. And then most people are going to add the 5 over. And the reason most people are going to do that is because we're used to horizontal lines having that form, y equals a number. Now, to be truthful, I could have skipped all of this. I could have skipped all of this stuff. I just wanted to show you that you could still discover it on your own without memorizing this. Horizontal lines always have the same y value. No matter what point you pick, the y values stay the same. So if you wanted to go through -1, 5, it means all the y values have a value of 5, and the equation is going to be y equals 5. So really, you could just skip straight to that if you really understand those connections well. You don't want to memorize a little bit more of those connections, you can just do it the long way. Plug in 0 for the slope and simplify it a bit. Okay, and then last one of these before I pause and give you guys a chance to speak up. So, in question 3, once again, they give me a point. I'm going to go towards point slope. And I am almost done with my answer, but I still need to know the slope. So, just like the last 3 questions I did, slope is really the only thing that slows me down since I know point slope form. Now, for this question, they don't tell us 2 points, so I can't do it like 1 and 4. And they're not telling me this is a vertical line or a horizontal line, so I can't do it like question number 2. But there are a couple things you need to remember about parallel versus perpendicular lines. So parallel lines look like this. They never touch, and the way that they're never going to touch is if they're rising or falling at the same rate. In other words, they have the same slope. Whereas perpendicular lines look like this. To be perpendicular means you intersect at a right angle. And to make them intersect at a right angle, the slopes need to be opposite reciprocals or negative reciprocals. Some math teachers say negative reciprocals, some say opposite reciprocals. So we know reciprocal just means you flip your fraction over. The opposite just means the opposite sign. So if one of them has a positive slope, the other one needs to be negative so that they're opposite. So I can look at this guy and say he has a slope of +4. So the opposite of that would be negative, and the reciprocal of that would be 1/4. Making him have a slope of -1/4 makes those 2 lines intersect at right angles. Now, this is probably more than you care to know, but just kind of an interesting, oh no, I don't have it in here anymore. An interesting calculator thing that you may have never thought of, but that they actually have a fix for, is I'm going to graph these two. Maybe. Okay, so I'm going to graph these two, the 4x plus 2 and my answer. I did that in my calculator. And these are supposed to be perpendicular. So, Jacob, what's it mean to be perpendicular?
They have the opposite slope.
That's close. That's good enough. Opposite reciprocal slope. But what should they look like?
An X
Okay.
or T maybe.
All right. Forget I asked. Perpendicular. These should be right angles, right? Do these look like right angles? How come? Why don't those look like right angles if they're perpendicular?
The y-axis is usually,
It's more smushed.
yeah.
Well, I don't know if that's very mathematical, but yeah. Your calculator has more pixels horizontally than it does vertically, so it actually has to stretch the image out a little bit. So, I don't think this is ever going to apply in this class, but if you ever wanted to check to see if two functions were parallel or perpendicular like this, you can graph them, and then if you go to zoom, instead of saying zoom standard, you pick zoom square. Your calculator adjusts it, and it knows it wants you to see like the same amount of space horizontally versus vertically. And then now can you see that they really are good, perfect right angles there? But again, you have to change your zoom to square to be able to make it look like that, because otherwise this is stretching the image horizontally a little bit. So again, I don't think that really matters for this class, but still kind of an interesting thing that people have thought about and have a fix for. So these first 4 questions were all about slope form, point slope, horizontal vertical lines, parallel perpendicular lines. Is there anything that jumps out at you that you'd like to ask about before we keep going? Okay, so I know you need to practice that stuff more, but you have seen all of that before. Most people have not seen anything about direct variation for questions 5 and 6. This is where I said there is a little bit of new information sprinkled in. But it's mostly the same thing with one exception. You need to know 2 things to be able to work direct variation questions. If something is direct variation, it's implied that it goes through the origin. So there's a hidden point as soon as they say direct variation. And the other thing you need to know is that instead of calling the slope m, we usually call it k. I don't know why. I don't know the background on it. And instead of using the word slope, it has its own term, constant of variation. But the constant of variation is just a fancy way to say slope. So you need to know that about direct variation, and you need to know it goes through 0, 0. But that's enough. If you know those 2 things, these are not any harder than the first 4 questions. Now number 5 has 2 points. So if I wanted to know the slope, I could use the slope formula. If I wanted an equation, I could plug in a point and the slope into point slope. And just try not to overcomplicate it. That's all that needs to be done. Okay, question 6, same thing, but this one has 2 questions. One is it wants to know what's the constant of variation, which is really just a fancy way to say slope. And it wants to know what is the y value when x is -2. So this one has 2 parts to it. Well, because it's a direct variation question, and that means it goes through 0, 0, They gave me a second point here, negative 1/3 6. So if I need to know the slope, just do it like we've done the last 5 questions. Subtract the y values over subtract the x values. Just make sure that you're careful dividing a fraction. Dividing a fraction is the same as multiplying by the reciprocal. Negative 18. Negative 18 is the slope. We just call it constant of integration. Second half of the question, this is really trying to show you that this is what an equation of a line is, almost like a formula to give you all the solutions, as a visual of all the solutions to that equation. So even though this question doesn't say write the equation of the line, I can do that very quickly. I could pick a point to use, even though it doesn't matter. I don't want to use this point because I don't want fractions in my work. So I'm going to plug in 0, 0 into point slope. I know the slope. I can simplify the equation. And again, the equation is like a formula that tells you all the solutions. So if you want to know what y is when x is negative 2, you just plug negative 2 in for x and solve for y. So if you look at my work on question 6, it doesn't really look much different than what we did in questions 1 through 4. The two keys is again, it's almost like a vocab question. As soon as it says direct variation, there's an implied point at 0, 0. And when it refers to constant of variation, you need to know that's just a fancy way to ask about slope. Now, I know most of you have never heard of those before. So on worksheet 2, there's 2 more questions like these. But then on the extra practice worksheet, there's another 2, because I know students always want a couple more of those to practice. So we may not get to the extra practice piece today, but you should get to the worksheet 2 at least. Okay, since that's all I have on direct variation on this worksheet, is there anything you'd like to quickly get clarified? Okay, then the next section is about graphing some different things. So actually, before I do these 4, let's skip down to the next to last question, because I think that's going to help us with our first graphing one. Hopefully I've convinced you that point slope is better than slope intercept, but slope intercept is still a math term. We still need to be familiar with it. In fact, it's pretty much the only way to graph in your calculator. You guys know that you can't go to your calculator and ask it to graph this. So if you wanted to graph it, you'd probably just solve it for y equals, because that's how your calculator takes it, and that is slope intercept, mx plus b. So take away 2 x's from both sides and divide both sides by -5. Now it's in y equals mx plus b format. Rearrange it to y equals so that it's in slope intercept form. So I specifically wanted to do that one first because that's what I'm going to do with the first graph. Slope intercept is a nice way to graph. So if it's not in slope intercept form, like question 7, let's put it in slope intercept form. Take away 2 x's from both sides. Divide both sides by a -3. Now I can instantly see the y-intercept is -4, and I can instantly see that the slope is 2/3. So take this point that I'm sure is on my line, count up to, write 3. You really only need 2 points to define a line, but if you do it multiple times, your line might be a little more accurate. So up to, write 3, up to, write 3. Connect them and you're done. Oh, that didn't show up very good. Okay, that was a little sad. So that is one benefit of slope-intercept. It's pretty easy to graph. Point slope is just as easy to graph. You also start off with the point and use the slope, but I think that's what you guys would do. All right, 8 should be super quick. So on the other page, we reviewed the difference between a vertical and a horizontal line. So since this is in the form x equals a number, I know this is a vertical line, and it's the vertical line where x is always 4. And that's it. Probably the hardest graph is going to be the piecewise function. Piecewise is the thing that we will practice more of besides this one section. And I know we've looked at piecewise functions just a touch in here, but this is one of the things, piecewise functions are super important in calculus. And you guys just struggle with reading these. I think you just don't get enough practice on them. Okay, so how I would graph a piecewise function is I'm just going to graph all 3 pieces. Sometimes it's y equals -4. That would be a horizontal line. Sometimes it's y equals 2. Also a horizontal line. And sometimes it's y equals 3x minus 2. That's slope-intercept. So I plot the y-intercept for point 1. Use the slope up 3, right 1 to find the second point. Now, I'm almost done, but it's called a piecewise function because I'm really only supposed to be keeping a piece of each of these, which is what this stuff is. Also, just kind of a quick little check, if this ends up being a skill that's hard for you. Pay attention to this. This f of x, we are saying this guy is a function. And we know to be a function, it has to pass the vertical line test. This certainly doesn't pass the vertical line test. So there's no way this is a function. There's no way this could be my final answer. So the rest of this, the restrictions over here, it's supposed to be y equals -4, but only when x is equal to -2. Equal to means a filled-in circle, and less than -2, which would be the stuff to the left, not the stuff to the right. So I erased this, because this is the only time it's supposed to exist. The middle piece is only supposed to exist during these times, when x is bigger than -2, not equal to -2, so that's an open circle, but less than or equal to 1. So equal to 1 would be a closed circle and all the x values in between. But not x values less than -2, not x values bigger than 1. So I would take those away. And then finally the last restriction, it was y equals 2, but only when x is bigger than 1. So it doesn't say equal to 1, so that would be an open circle. And bigger than 1 would be the stuff to the right, not the stuff to the left. So again, I don't know. This is one of the things I just struggled to understand why y'all struggle with these sometimes. But if you can graph this, just keep that part. Graph this, keep this part, and then graph that and keep that part. And then you've got your piecewise function. By the way, notice mine does pass the vertical line test now. Over here, it only hits one line. Over here, it only hits one line. Over here, it only hits on one line. And notice these open closed circles. At x equals 1, it hits 1 time, not 2 times. This is why we need to keep up with the closed circle versus open circle. It hits here, but not here. Also at x equals -2, it hits here, but not here. Still passing the vertical line test because it's only hitting once. So now that my graph is actually a function, it's likely to be correct. Okay, next to last one, and this is actually going to come into play with question 12. So this one seems a little bit random, but we need you to remember what the square root of x graph looks like. This is one of those parent functions. He goes through the origin, and he has a V shape. And then just apply transformation rules. If you're subtracting 1 directly from x, it would shift it right 1. But otherwise, it's still going to look like a V. Okay, so on to the last question, which is probably the hardest to sink in. It takes the most thought, so make sure you're giving me your full attention here. Now, we are going to change an absolute value function, and we're going to write our own piecewise function. So I'm going to take this guy and make him look like one of these guys. I'm going to split it into 2 equal pieces. Now, before I show you how to do this one, because this is the harder version, I'm going to show you the easier version. This is the classic example. This is probably what's in your textbook somewhere. But let's just do the absolute value of x. We're supposed to know what that graph looks like. It's a parent function. And his piecewise function's a little bit easier to understand why he's set up this way. Sometimes the graph looks like this. And sometimes the graph looks like this. I'm going to do them in different colors to help you see that. Imagine this red one. You can imagine it keep going even though it doesn't. What's the equation of this red line? Good. It's x. Y-intercept of 0, slope of 1. What is the equation of my purple line? Very good. Also, y-intercept of 0, but a slope of -1. This is going to, what I'm about to say is about to do half of this question for you on number 12. So I don't know exactly what this one looks like, but since I'm subtracting from x, I know it shifts its sum to the right. To know what this 3 does, you don't need to know this for this class, but the vertical stretches and shrinks versus horizontal stretches and shrinks. This is a horizontal shrink by a factor of 1/3. That's not going to matter. We don't have to remember that to do this question. But notice over here, one of my equations was the stuff under the absolute value sign. So the same's going to be over here. The stuff under the absolute value sign is one of my equations. The other equation is the opposite of what's under the absolute value sign. So instead of x, it was -x. Instead of 3x minus 1, it's negative 3x minus 1. Or just distribute. So that's half of the work. One equation is the stuff under the absolute value sign, and one equation is the opposite of the stuff under the absolute value sign, just like this one. This one's easier for you to grasp, but you can see where it comes from. Now over here, we can easily see that it's switching hands at x equals 0. So this restriction is going to change at x equals 0. X equals 0, x equals 0. You need to be careful with your inequality signs. If this red line is when x is greater than 0, make sure your inequality says when x is greater than 0. If my purple line is when x is less than 0, make sure your inequality says when x is less than 0. Okay, now this is kind of a challenging question, but I really need one more thing to this piecewise function. Does anybody have a guess about what it's missing? Something to do with the highlighted point. Right. If I don't include 0 with this function and I don't include 0 with this function, technically there would be a hole right here, and there's not supposed to be. So you either need to include 0 with this one or this one, but not both. And honestly, it doesn't matter. But you need to include one of them so that there's not a hole there. Okay, so for us to finish, we just need to figure out right here, when does it stop being the purple function and start being the red function? So this was a little more obvious that this was happening at 0. This is not so obvious. I know it's to the right because I subtracted from x, but short of that, I don't know off the top of my head. But I think you can all agree that from this terrible picture that this has a y value of 0. It's on the x-axis. So I could figure out where this red line is when y equals 0. Or I could figure out where the purple line is when x equals 0. You could do one or the other, and it turns out that these are at the same time and the same place when x is 1/3. So you don't need to be creative to try to figure out that 1/3. Just realize it's where y equals 0 and set either of them equal to 0 to solve for x. That's occurring at 1/3. Now be careful with the direction the inequality sign points. I want the right of these, so where x is bigger. I want the left of those, so where x is less than. And then to make sure that you don't have an open circle here, you need to include this or this. Doesn't matter which one. Just include one of them, not both, not neither, but one of them. Doesn't matter otherwise. So again, when we get to the extra practice, which we'll save that one for Monday, we'll practice 2 more of these just because I know they take a little more practice. But there is some patterns there. It's not as challenging as it first appears. There's quite a bit of it that you can just pull straight away. Okay, so what I'd like you guys to do, even though we had a little bit more time than the rest of the classes, to make sure you guys at least get to that, because you've got 29 minutes. What I'd like you to do before you call it quits for today is go ahead and try the 110 worksheet. It's got the same question types as the one I just went over with you. And then that way on Monday we can start by going over it and you can see which ones you did right and which ones you need to ask about. So with your last 30 minutes, please work through handout 110. And I guess you're welcome to do 111 if you want to, but you're also welcome to save 111 for Monday. So. All right, and then that will be it for now. So again, we've got like 3 different topics in this unit: linear, quadratic, and piecewise. Everything we expect you to know about linear is on these 3 worksheets. So practice worksheet 2, so you can see how much of it you remember / picked up from worksheet 1. We'll go over it on Monday, try to fill in the gaps. We'll get a little extra practice on the 3 question types that students have told me in the past that they want extra practice on. And then we will move on to solving quadratics on Monday.